So good morning, Mat2 student, IDTH 232. This is the second part of the lecture on data analysis, interpretation, and reporting of results. I have shared with you part one, which consisted mainly on data analysis, going through all the steps. So I'm going to start with an illustration, at least to wrap up and make sure that you have everything about data analysis and the step we do with a very relevant example. And I'll continue with reporting and interpretation of results. So starting with the first slide. So the slide is, I chose a topic that's very relevant. This is about knowledge and practice of preventive measure related to COVID-19. So the study had the three objectives: assess the level of knowledge about COVID-19 among general public, to measure the proportion who are using preventive measures, specifically wearing masks, and to investigate the relationship between knowledge, practice, controlling for potential confounding. Therefore, my outcome is wearing a mask when you go to supermarket or to your work, and this is a binary variable with a yes and no answer. The independent variable is knowledge, that consists of a list of 20 knowledge questions that are coded 0 and 1, and therefore we can have two types of variable: a continuous variable, which is a score from 0 to 20, and we can consider it as a continuous variable, and a categorical variable based on grouping the scores into two categories. You can decide on a cutoff and have an adequate versus inadequate knowledge. The covariate or the potential confounders are education, three categories: gender, male, female, age, continuous, and if you know someone with COVID-19. So how do we start? Always with a univariate analysis, looking at that will allow us to give us the profile of the sample of the general population in terms of age, gender, and education. And this is usually your table 1. The second is to describe your main dependent variable and independent variable. And therefore, if I take knowledge, so I want to assess level of knowledge, I can compute the mean and standard deviation of knowledge score and give a 95% confidence interval of the mean. I can do an item by item analysis on knowledge and look at what's the proportion who answered correctly on every knowledge item, and this is important to keep so you would know where are the gaps. And you can have a frequency distribution of knowledge adequacy, which means what's the proportion who have adequate and inadequate measures. Again, n%, and you can have a 95% confidence of the proportion to see how precise is your estimate. And to have to measure the dependent, you can have a frequency distribution of the general public wearing mask or who reported wearing mask. And this is a proportion, and therefore this is your table 2. So this is your univariate. Of course, you should have done your data cleaning, look at variability, how many female, males, etc. But this is where you will put all of the profile of the sample. So we move into the bivariate, and the bivariate, I have two major associations to look at. One is the most interesting one, and this is what I want to get out of the study, is to assess whether my outcome is related to my exposure, and this is knowledge as related to practice or wearing mask. So if I consider knowledge as a continuous variable, this means that I want to compare mean score on knowledge between those who wear masks and those who don't. And I have to have or compute a t-test and a p-value. So this is the kind of table I want. But if I consider knowledge as binary, so the way I analyze is I generate a contingency table, which is a cross tabulation between knowledge, adequate, not adequate, wearing mask or not wearing mask, and then you will have the chi-square test, and what you can calculate is the crude OR, which is the odds of wearing mask for those who have inadequate knowledge compared to adequate knowledge, or vice versa, depends how you want to see it. But this is called a crude OR because it is only between two variables. It's a bivariate analysis. And we, of course, with the OR, we calculate a 95% confidence interval. This we call it crude or unadjusted OR. Also in the bivariate, in order to take into consideration or to account for confounding, at least one of the things that I can do is look at whether my confounder, potential confounder, are associated with the independent variable, because my confounder have to match two conditions. One, to be a confounder, they should be related to the outcome. It means if the outcome here is wearing mask, but they should be as well associated with the independent. So I can at least check one of those conditions. So I look at the association between my knowledge, adequate, not adequate, and age, education, and knowing someone with COVID. So I cross-tabulate wearing mask. Oh, sorry, what I put here is between independent, but what I did is dependent. It's okay. So so therefore you can do either one. So here I said cross-tabulate between wearing mask by gender, education, and knowing someone with COVID, and compare the mean age of those who wear masks to those who don't. Again, I will not go over the lecture again, just to say that what I did is association between dependent, but you can as well do association between your independent knowledge and the potential confounder. In the multivariable analysis, you consider all variables whose p in the bivariate was, again, less than 0.2. Excuse me for those mistakes. It's less than 0.2. Please correct. I'm going to correct it in the handout that I'm going to post on Moodle. And then you run multiple logistic regression to compute adjusted ORs with their confidence, 95% confidence interval. For example, if knowledge is considered as a continuous in the regression, the OR reads as follows. Every unit increases knowledge is associated with so much, so the odds of wearing mask is multiplied by X. So just to say, these are the steps that you have to follow when you have when you're doing an analysis, okay, statistical analysis. Now we're going to reporting of results. You finish your table, decide what figure you want to show, and then you write the text later. The text supplements and reinforces the table and figures. And you have to think, you have to keep in mind this, that the text should stand on its own, and the table should be self-explanatory, and each one supplement the other. So the text and the result, when you start writing, please summarize and emphasize, highlight. You don't have to write every single result you have, every single number that you have. For example, you don't have to say that I have 54% male and 46% female. So by the fact that you put 54% male, we would know, the reader would know that the remaining one are males or are females. So we have to be brief in the text, because if you have a table and figure, these are really much more illustrative than a statement, one sentence or two sentences, and we say that a picture is worth 1,000 words. Make sure that your text is really consistent with table and figure. Okay? Always compare. When you what do you put in the text? Usually you want to look at the size and shape of the pattern. So how large is the association? Is the magnitude high or low? And then if you have a hypothesis, you have to say that whether this is a hypothesis is rejected or accepted. So most importantly is to look at direction and magnitude. So which is higher? So if you have a list of items for knowledge, which item has the highest proportion of correct answer, for example? If you have several odds, which odds is higher? Which category gives you a higher odds for association? So always you have to think about this. So you show magnitude, you show direction, and when you go over a table, result in a table, you have to use the same ordering principle as in the table or chart. You don't people to zigzag in the table, or if they are reading the text and they go and check the table, they're not able to associate where. So it has to have the same order and as in the table. So tables and figures need to be really simple and appealing. Simple and appealing is the issue, is the keywords. So table should be self-explanatory, and therefore the title should be very clear. You should have explanation of, you can use as much footnote as you want to clarify labels, footnote, explain sometimes categories. And then you can always, please do check your math. Sometimes the reviewer would look at your tables and find that they don't add up to 100, they don't add up to the sample size that you have put. So please always check your math and be consistent in terms of row and column summation. So either all row percent or column percent. Try to keep your lines to a minimum in terms of row and the column lines, and usually avoid vertical lines. And then always check heading, label, and label rows and columns, so on and so forth. So how do you order the variables in a table? So again, as we said, when you put tables and a variable in a table, so if you have some table that fall under one particular concept, so you put them into, you put them together. So for example, if you have a list of variables that are socio-demographic and health-related variable. So I would have a broad category called socio-demographic variable. Underneath it in the table, I will put age, gender, marital education, marital status education, and another title, which is, or a subtitle, which is health status, and I put under health status having diabetes, etc. Another one could be lifestyle factor. So you have to avoid zigzagging and back and forth in a chart from row and column and table. So you have to think about what kind of a pattern. Another way of arranging variable in a table, I'll give you an example of the knowledge score. So if you have 20 item knowledge score and you want to show the items where people correctly answered those items. So instead of putting them the way they appear in the questionnaire, I put them from those where the respondent gave the best answer to the low. So ascending or descending order, to most to least common. Anything, it's nice to have an order rather than your reader trying to find which is the most commonly cited reason, for example. So start with the most commonly cited reason. Start with the most commonly, the one that most of them got it right, to the item that most of your participants got it wrong. Okay. So a principle of organizing, again, never arbitrary. So you don't put the variable in a table in an arbitrary format. Always think about how they group, they are grouped first together. Okay, so this is one. Ordering the way they are appear in the instrument is not the best strategy. As I said, if you have this 10 item or 20 item knowledge, you don't put them as they appear in the text, but in an empirical order. Empirical order meaning that from highest to most common to the least common, or least common to the most common. And theoretical grouping, this means that if even these 20, they fall under different subgroups, you can put them under different subgroups. So let me give you an example. This is a theoretical grouping. So this comes from a study on musculoskeletal symptoms and treatment for musculoskeletal pain. And the people answered as a general practitioner, family practitioner, rheumatologist, orthopedic surgeon, neurologist, and endocrinologist. So one way of putting them in a table or in a graph is to putting them from highest to lowest. So highest to lowest is starting with rheumatologist, then GP. So when you talk about it and the result, you would say that the most commonly source of treatment is the rheumatologist, which is really good, followed by. Another way of putting it is to look at those source of treatment in terms of the type or the practice. So you can put under general medicine, which is GP, family practitioner, rheumatologist, and then the others, which are orthopedic surgeon, neurologist, and endocrinologist. So as we said, if we want to present the data, this is another way of presenting the data. So this is distribution of respondent by depression status, work status, and selected covariate. So this tables give you several things. One, it gives you the total. So the total meaning that I can know how many are, for example, work status, how many are former workers, how many have been always in the same job, the age grouping, etc. But at the same time, it gives me again, it's a bivariate analysis. So what's particular about the table? It's not very crowded table. So this is my dependent variable depressed. So instead of looking at depressed and non-depressed, I choose to present only the depressed. So percent depressed, because I can always deduce those that are not depressed. And ultimately, when what I want to compare here is the percent depressed among former worker compared to current worker, and say that former workers, so those elderly who are not working, are 2 times more likely than current worker to be depressed. So this is in terms of proportion. And what I added is another unadjusted variable, unadjusted odds ratio, excuse me, and unadjusted mean. When I compare the current worker to the former worker, so the reference here is former worker, so those who are currently have lower odds of being depressed compared to former worker. It means that working now is protected. Is it significant? Yes, with a confidence interval not overlapping with 1, and the p-value is less than 0.01. So this is a kind of table that's presenting data it's a bivariate analysis, but has a lot of data because it gives me distribution of the variable. It gives me the simple 2x2 distribution, but by not showing everything, but only the percent depressed. And at the same time, I'm providing you with a measure of association, which is the OR. So in the result, please don't present all the result, only the salient aspect of the table and graph, because if people want good details, they go back to the table or to the graph. Okay, so, and you want to present only a result that relate to your research question, because sometimes you collect a lot of data and you don't have to present them all in one paper. So only related to your research question. And again, the most important aspect of the table and graph, not every single statistical quantity, and try to vary always the method of presenting your quantitative finding, and provide a mixture of diagram and table. So tables, figures, etc. So people are not bored one day. So again, the result, as we said, you present the table of the principal study variable at the first time, broken down by demographic characteristic, take every research hypothesis one by one, and then you state the finding and you document detailing the evidence, and you don't have to constantly refer to the table to understand the findings. So that's why I said from the beginning is that the text supplements and reinforces the table and vice versa. Okay. So in the discussion, the discussion of your results. So this is, you put all your results. So it should start and end with a brief summary highlighting what your research. Don't repeat result in the discussion. So this is not the place where you say another 10% of the people wear mask. So if we refer to my illustration on wearing mask and knowledge, you can start with saying that a low proportion, or it's surprising that, or maybe as expected, for example, knowledge related to COVID was low, and then we had high proportion who were wearing masks, and knowledge was not related to wearing masks. So just brief summary, the highlight of the research. Again, you always go back to your objective. You don't have to present everything. The first thing in the discussion, you have to say is your major finding based on what the objective. And then you place the whole research into broader perspective. So how do we compare to others? What do the results, what do they mean? What do they mean? What are the implications? What can you do? So can you chase things? Should you focus on a particular group of interest? And of course, always you have to point out to the limitation of your research, any inconsistency, and suggest improvement in the study design. Limitations are very important. They are much important than the strength. So you put your limitation, you acknowledge that there might be some limitation related to information bias, selection bias, recall bias. If you have a lot of missing data and your missing data are might give you some, might lead to some information bias. You have to acknowledge if you have a high non-response rate or even a low response rate by you, but your respondent were different from your non-respondent. This means that you might have a selection bias. So therefore your sample does not represent anymore the original population that you intended to survey. So this also need to be acknowledged. Selection bias, information bias, and of course you can highlight the strengths of the study in terms of its originality, its rigor, it's maybe its large sample size, the concept, the valid tools that you have used, and always mention the theoretical and the practical implication, okay? And how do you want to build on those data? So in a nutshell, I highlighted what you should do. So first you have to compare your result to others, and this is primarily descriptive. Discuss potential biases, as I said, so I'm not going to repeat it. And as you are discussing the potential biases, you have to reflect on how such a bias would change your estimate. So is it like inflating the estimate, or is it pushing the estimate to the null? That's why you didn't get any statistical association. So how is it working, those limitation or biases? Assess your confounding. So did you take into consideration the confounder? How did you deal with them? How much of the effect was explained by those confounder? Did you miss to maybe collect more data on confounder? And always you have to assess the meaning and significance of your finding. So what? Okay, and how are these associated? What does it mean that, for example, knowledge associated with wearing mask? What does it mean that stillbirth is related to autism? So what's the biological explanation? Do we have a causal pathway? What further studies do you propose for your hypotheses, and what are the policy implication or practice application? Sometimes you would recommend some kind of an intervention or a change in practice, or it could be also, you could guide policymaker to changing things. For example, in the issue of wearing mask. So how policymakers should think about it? What kind of intervention would you do? At what level is the intervention? At the level of the pharmacy, at the level of the population, at the level of the mass media? And it's good to say, how confident are you in making your recommendation? These are just illustrative table. This one is on just profiling the sample, demographic characteristic of the sample. These are the main socio-demographic variable. This is another, again, descriptive table on describing pain and disability among participants with rheumatic diseases. This is not a bivariate analysis. This is simply describing the data and looking at the mean pain intensity using the visual analog scale between those who have mechanical disease, inflammatory disease, with pain description in terms of categorical or ordinal, mild, moderate, severe, and the difference between mechanical and inflammatory. But again, this is not a hypothesis testing, it's just describing, comparing mechanical and inflammatory in terms of the pain intensity, pain description, the level, and how much have disability if they have mechanical compared to inflammatory. But again, this is more description. This is bivariate association of study variable between cases and control. Here, cases are those who have osteoarthritis, and control are those people who don't have osteoarthritis and no pain in the past 6 months. And we are comparing cases and control with respect to some risk factor: cigarette smoking, physical activity, educational level, monthly income, and altitude. And I can take one of them to illustrate. So I have OR. Since this is bivariate, therefore this is unadjusted or crude OR. So I'll take this one. So this means that ex-smoker, okay, have 3.2 higher odds of having osteoarthritis and being a case compared to a non-smoker. So they have higher odds, and this is significant. If I take another one, those who have a low educational level are at higher odds of having osteoarthritis compared to those with high or medium educational level, and this is significant. First, the CI does not overlap with one, and the p-value of the chi-square is significant. And beneath, we explain what is high and medium, what is low education, and this is what I say, that this table should be self-explanatory. I don't have to go back to the text to understand it. So here is, we have a mean altitude. So here the altitude is continuous, and we are comparing the mean altitude among those who have osteoarthritis, which is 536, compared to control 347. So apparently cases are living on high altitude. Is it significant? Yes, it is significant. So, and when we do a final multivariable logistic regression on the same data, what we put in the analysis are 4 or 5 variable. So geographic location, body mass index, type of job, family history. Of course, this comes from several tables before, but I showed you only, this table is done only for illustration. So we have a longer table. So when we put those that have a p-value less than 0.2 and we put them in a final multivariable model, it gives us, this is adjusted ORs, and the way it reads is that those who reside in the north have a 6.5 higher odds of knee osteoarthritis compared to those who live in Beirut and Mount Lebanon. This is related mostly to altitude, and this is significant. Body mass index, again, obesity is associated with knee osteoarthritis, controlling for geographic location, type of job, family history, monthly income. So therefore, these are adjusted for the remaining variables that are in the model, so on and so forth. And goodness of fit, so does the data fit? Does it fit? Does this variable, does it fit? Do the result fit the data? Sorry, do the result fit the model? So if this is not significant, it means it fits. If it were significant, it means it doesn't fit. Okay, and I think that's all. We'll have a chat, or you can send me an email if you have any question, and I look forward to hearing your reflection and result on April 21 and 22. Anyway, I will follow up on that in a separate email.